Hello and welcome to EELE 101, and this week we will look at adding the Freescale Cup Shield to the Freedom board. Okay, so if we look at the shield here that comes with your race car kit, what this shield contains is two motor ICs. Okay, so this is going to control uh, the motors that are driving the car. We'll have two servo outputs. Okay, so this is what one of those will control the steering. We have two line camera inputs. We will just be using one to get information from the line camera, so that's where we'll be looking for a black line. There's speed sensors, there's potentiometers, there's push buttons, okay, there's a dip switch, and some LEDs that we have the capability of using, okay. Should point out here that information regarding the shield can be found at the following link, okay. And here you can get code, schematics, and videos. Alright, so the first thing that needs to be done is to get 4 header posts on the board. Okay, the older kits didn't have this on the Freedom board, so you actually have to solder these header connectors. The newer kits have this already done for you. So depending on whether you have a newer or older kit, you may have to do a little bit of soldering. Okay, so let's assume you've got the soldering done. Then you'll just plug the Freescale Cup Shield onto the board and it will look like the following. Alright, okay, here's a little busy slide here because there's a bunch of instructions here. The first thing that you need to do is actually go to that link because there is a video that you should watch. Okay, so go to the link, and if you scroll down about halfway in the page, or there's also a link at the top, okay, there's this Freedom TFC example. Okay, alright, so if you see that video, the Freedom TFC example code getting started video. Okay, watch that because that sort of walks you through a bit of the code and how to download and get the code. However, the steps on how to get the code have changed. So you can pretty much skip this section of the video, okay, because that is actually not supported anymore. I suppose in the future it may. So in order to get the code or the project that you can import into CodeWarrior, there are two ways of doing it. Method one, the easy way, this is actually the way I would suggest that you do. Alright, so go back to the same web link. Okay, you want to scroll down halfway down into the page. It's actually just past the videos that are on that web page, and there's a couple of attachments there. There's one called Freedom TFC R1.0.zip. So download that file. So this is revision 1 of the code, and unzip it and have that unzip directory available. Then in CodeWarrior, for CodeWarrior, create an empty directory that will be the workspace for CodeWarrior. And then when CodeWarrior boots up, just point to this empty workspace. Okay, and then you want to import the project, which will have this directory name. So in CodeWarrior, there's File, Import. You can use the Select panel to, if you expand it, say you want to, the source is existing projects that you want to bring into the workspace. You want to make sure that you're actually copying everything that you need into the workspace. Okay. And then you actually at the top, browse and actually select that directory as the source. Click Finish. It should import it all in there, and then if you're at the welcome page, click Go to Workbench. Okay, to actually bring you to the code. If you watch the video, it actually showed you how to do this as well. Okay, so just like you did last week, this is now a different project that you are importing. In fact, this is the code that you will be using for your car. All right, a little bit more difficult way to get the code, but this is to get the latest version, which is actually not necessary for the course, but down the road, if you come back and want to see if there's a later version, you can actually go to Google Code and check out that code using SVN. Okay. So this implies that you have to have another piece of software installed on your machine, which is SVN. And this, in my case, I went with the Windows version and Visual SVN. Okay, and once that's installed, you actually just open up a Windows command prompt and you type all this into it. Okay, or cut and paste it in there. Okay, run it. This copies everything over from Google Code to this directory that's Freedom TFC read only, and then you import this into CodeWarrior, but you have to realize that there's also a bunch of other stuff that it copies over, so you need to go down into the releases directory, R1.0 directory, and then that is the directory that you import into your project like before. Okay, but let's assume that you do method 1 the easy way, and you get the code imported into CodeWarrior. All right, so to use CodeWarrior, just remember that you have to put your Freedom board into the CodeWarrior debug mode. So this is what you did last time, okay, not the flash mode, and just if it's not in there, just follow these steps so CodeWarrior can actually see your board. All right, let's look at the top of the shield and notice there is this dip switch here. Okay, so there's 4 switches. Okay, we are going to pay attention to switches 2 and 3 that are in the middle. Okay, if they're up, they're in the on state or the 1 state. Okay, if they're down, they're off, and the voltage you'll be reading is 0, which will symbolize 0 as well. Okay, so once the code has been compiled and you've downloaded it to the board, okay, you do this by doing, just like last time, run debug configurations, select the Freedom TRC Flash OpenSDA in the panel, okay, download that, and once it's all loaded, just remember you need to click the resume button here to get the code actually running. Okay, so for demo 0, what this does is if you push the push button A, okay, all right, one of the LEDs that are up here will light up, okay, and then the other push button will light up another LED. Okay, so that's all it is for demo 0, but it shows you that the board is working, and blinking LEDs is the hardware version of Hello World. Okay, so let's actually examine the code that's in the CodeWarrior project. Okay, so the video that you watch from the website, on the Freescale website, walked you through the little code a bit. We will go more in depth here on a couple lines of code. All right, so what you want to do is open up the main, .c code and go down to line 17, right, where you see it's line 17 or 18 depending on what the version of the code. Okay, but here you see the switch and this TFC get diff switch. All right. Okay, so the question here is, how in the world does this function TFC get diff switch actually get the information? And how does this tell us the position of the switches? How does this happen? All right, so here's the question again, but more visual term, is we have the switch on the board, and we can see the states of the switches, right? And we're calling a function that's going to tell us the state. So how does information get from the external world into our code? Okay, that's the question here. And we will dig down to answer that. All right, so the first thing that you need to know is how are things connected on the board? Okay, so the first thing that if you need to know how this is connected up is you have to look at the schematics. Okay, so here if you go to that link and you download this rev build package, it has a bunch of information on the board, including the schematics. Okay, and if you look at page 1 of the schematics, part of what you'll see is this here. So notice here we have switch 3 here. We have 4 switches on there, and this is connected to a line, and we have some resistors here and ground. Okay, so what does this mean? Okay, well, let's just look at one of these. So what actually happens is somewhere along this line it's going to get connected to this line here. Okay, they don't necessarily actually show you that entire connection, but given the label here, we know that that is eventually connected. All right, so what happens here? We have 3.3 volts here. Okay, we have a resistor and we have ground. Well, if this is open, like it's showing here, there's no voltage there, and since you know a little bit about Ohm's law now, you know that if there's a voltage across here, this will reflect the connection and see whatever voltage is applied here. Well, if it's open, there's nothing being applied here, and so any voltage that was there quickly goes across ground, and so this actually will be 0 when this switch is open. Well, if this switch is closed, okay, this pulls this line up to the 3.3 volts. Okay, and so what we have here then is either it's 0 when the switch is open, or 3.3 volts when the switch is closed. And that's coming to the freedom board. So here the switch is on the shield, okay, it now has to get to the freedom board, and it does it through this connector interface, which we also see on the schematics. Okay. All right, so it comes through the connector, and given the schematics, we know then that the voltages of those 4 switches actually show up on these 4 pins of the microcontroller. Okay, so this is how that switch information is actually showing up to the microcontroller. All right. Okay, so the other thing you need to know is now internal to the microcontroller, these pins actually get mapped to a particular register. And one of the things about learning the microcontroller is where is everything located inside the microcontroller, which are typically registers, and these are always memory mapped at some memory address. Okay, so this is what you have to go and look up the table saying, okay, I'm interested in this particular register because I know it's connected to those pins that I'm after. Okay, all right. So the point here is this is how information from the hardware side gets into the code, into our code. It is through registers that are memory mapped. Okay, and this is located at hex 4000F F110. Okay, right. So if your C code reads this memory location, it will read the values of these pins. Okay, and then there's also just a bit of a note here that there's another alias in there where at a different address it actually gets the same value. All right. Okay, so let's dig into this actual function. Okay, so we're going to right click on the function name. So if you go into your main, right click it, and you'll see this open declaration. Okay, so here we're going to be a code detective. So if we do that, actually a new window pops up and shows us this code. So this is actually a pretty nice tool that Eclipse has for browsing source code. Okay, all right. So we see that this function actually has an internal value called dip value, which is initially set to 0, and then we have this GPIOE PDIR, right? Which it does something to it, and then it returns the dip value. So here's the question: is what in the world is this thing? Okay, well, let's do our code detective work again. So we'll right click on it and select open declaration, and now we see it's a define statement. Okay, so here this GPIOE PDIR is defined to be this statement here. Okay, all right, well, that's still a little bit confusing, so we can find what this is, and we also see that this is also another defined statement. Okay, and this is using the base pointer. Well, it's actually using two things. Okay, we have register, PDR register, and PDR base pointer, which are two separate define statements. Okay, so what you should know about the preprocessor and the compilers, these define statements are just text replacements, and so it just actually goes in and substitutes those text values. And what this does is it ultimately rewrites using several define statements that GPIO PDIR is equivalent to this big statement here, okay, which is what it has before it actually then compiles the code. So what in the world does this mean, right? Okay, so let's sort of walk through that. All right. Okay, so this gets into some more advanced C, which I don't expect you to really understand at this point, but you should be aware of this is actually how your code talks to the hardware world, and it's through registers. Okay, all right. So the first thing is we actually have this memory address. Okay. And the statement says here, this here in the parentheses is saying we're typecasting this memory address to be of type FGPIO memmap pointer. Okay, so this is telling the compiler how to interpret this memory address. Okay, furthermore, since it's a pointer, we're saying actually go off and look, since this is a pointer to this entire data structure, okay, we're actually interested in just one of the fields in that, right? So this means go to this memory address, interpret it as this data structure, and go get information from the PDIR field, which is the port data input register, okay? And this is actually at a slight offset to this address here, okay, and we go to that specific memory location and grab the data there. Okay, so that's a bit complicated. I don't expect you to know all that, but you should be aware that there is a method of getting data from the external world through the CPU into a register. We have to go read that register, but we have to read the right register to get information. Okay, now this function then is reading a 32-bit register. Okay, so how do we get the information that we want? Okay, well, as we just saw, this define statement here returns all 32 bits here. Okay, all right. Well, in the register definition, if we looked at the the actual data sheet, we notice that these are the bits that we're after, and they're located at 2, 3, 4, 5 in this register. Okay. We don't care about all these bits up here, and we don't care about these 2 bits down here. We want these 4 bits, right? So how do we get these 4 bits out of the 32-bit register? All right. Well, the first thing you want to do is actually take the entire register and shift everything to the right 2 bits. Okay. That means these guys fall off and disappear. Okay. They fall off into the bit bucket and get vaporized. Okay. They just disappear. All right, so that's what this means, is shift 2 bits to the right. Okay, so that's what we've done here. We've shifted the entire 32-bit register to the right. Okay. Now, it's like, notice that these are just 4 bits. Okay, so since they have been shifted over, right, we want to keep these bits. Okay, we want to 0 everything up here. So now what we're going to do is AND with the BitMask. If we AND anything with 0, it turns it to 0. If we AND anything with 1, in this case F is 4 ones, 1, 1, 1, 1, we preserve these bits because ANDing anything with 1 keeps the same value that was originally there. Okay, so this basically says, okay, we just want a number representing those 4 bits right here. And we actually will return this as a unsigned 8-bit integer. Okay, that's what this is. The value has been defined to be. And then we actually then return that as the function call. All right. All right, so this function ultimately returns the value of the 4 dip switches. Okay. Now in our demo, this depends on the 2 middle switches. Okay. So we essentially have to do the same thing to the 8-bit value that we get returned. Okay. All right. So let's look at what this entire statement does. Notice this function has already done a lot for us. It actually gives us the value. All right. So now we essentially repeat this again, is because we're interested in the 2 middle bit values. We don't care about this one on the ones on either end. So let's get rid of them. Okay. So let's shift the entire 8-bit word to the right. Okay. So that's what we're doing here, is we're taking the result that we're getting and shifting it 1 bit to the right. Okay, so that, the other bit fell off here, disappeared. Okay, now we want to 0 everything over here and preserve these. So we, again, and with the appropriate bit mask, we want all 0s here, and we want 1, 1 there. All right, so this is actually 0, 3 is the hex number for that bit pattern. Okay, and when we AND that, this is the PT5 gets ANDed with 0. If that disappears, the PT4 and 3 get ANDed with 1 and preserves their values. All right. Okay, so this ultimately gives us a number 0 through 3, depending on what the 2 middle values of the switch statements are. Okay, and then in our code we are testing to see what that is, and if both middle switches are down, that will be a value of 0. So our switch statement will say, oh, what's the value? Case 0. Oh, if it's 0, then run this code here. And now notice, if the push button is pressed, an LED 0 will be on, otherwise it will be off. And that's how we get information from the external world into the microcontroller, and then the microcontroller can send information out in a similar manner to light up an LED. Okay, so your assignment for week 7 is to get the Freedom board and the shield attached. Okay, so that's what we need to do here. Watch the video that's located on the site. Okay, and here's the link for that. Right, and following the steps outlined here, get the example project into CodeWarrior, and ultimately your assignment is to get demo 0 working. And you'll have to show that when you press one of those push buttons, an LED lights up. Okay, there's no quiz for this week, and there's no code to upload. You're just running code that has already been written for you, but we want to make sure that you can get that into CodeWarrior, downloaded to your board, and actually have it running. So good luck getting demo 0 working.